2.3 million stone blocks, each one weighing an average of 2.5 tons. Some weighing over 80 tons. Stacked with a precision that would challenge the most sophisticated modern construction equipment. And they did it 4,500 years ago. Without steel. Without wheels. Without the tools we consider essential for any major construction project. The Great Pyramid of Giza isn't just an ancient monument or a pharaoh's tomb. It's an engineering impossibility that we still cannot fully explain, a testament to human capability that raises profound questions about what ancient civilizations could achieve. But to understand why this matters, we need to examine exactly what the ancient Egyptians accomplished. Not the myths and legends, but the actual measured facts. The Great Pyramid was built around 2560 BCE during the reign of Pharaoh Khufu, known to the Greeks as Cheops. For nearly 4,000 years, it stood as the tallest man-made structure on Earth, originally rising to 481 feet before erosion and the removal of its smooth outer casing stones reduced its height somewhat. But impressive as that height is, it's not what makes the Great Pyramid remarkable among archaeologists and engineers. What truly sets it apart is the precision. Let me give you some numbers that illustrate just how extraordinary this precision is. The base of the pyramid covers more than 13 acres. That's roughly 10 football fields. And this massive base is level to within just 2.1 centimeters across its entire 756-foot length. That's an error of less than 0.1%. To put that in perspective, many modern construction projects don't achieve this level of accuracy. The foundation of a typical modern building might be off by several inches across a similar span, and that's considered acceptable. The four corners of the pyramid are almost perfectly square, with an average error of only 12 arcseconds. If you don't work with angular measurements, that might not mean much to you. So let me translate. The corners are so precisely square that the error is essentially unmeasurable by ordinary instruments. The sides are aligned to true north with an accuracy of 3/60ths of a degree. Modern surveyors using satellite technology would be hard-pressed to do better. How did Bronze Age engineers achieve this with copper tools, wooden measuring rods, and sighting instruments no more sophisticated than a plumb line? How did they create something so mathematically perfect without telescopes, without GPS, without laser levels, without any of the technologies we rely on? These questions have fascinated engineers, archaeologists, and historians for centuries. Let's examine what we actually know about pyramid construction, separating established facts from speculation. First, we know who built it. Contrary to popular myth, perpetuated by everything from biblical movies to science fiction, the pyramids were not built by slaves. Archaeological evidence from workers' villages near Giza has fundamentally changed our understanding of pyramid construction. The pyramid builders were skilled laborers, not enslaved people. They received medical care, we found healed bones and evidence of surgery. They ate meat regularly, a luxury in ancient Egypt. When they died, they were buried with honor near the monuments they constructed, in tombs that show clear respect for their service. Graffiti found inside the pyramid itself, left by work gangs who wanted to be remembered, includes team names like Friends of Khufu and Drunkards of Menkaure. These weren't the marks of enslaved people. These were proud workers who wanted future generations to know they had been part of something magnificent. We also know some of the logistics thanks to remarkable discoveries like the Wadi al-Jaf papyri, found in 2013. These ancient documents describe the transportation of limestone blocks by boat along the Nile and through a network of canals that connected the river to the construction site. Archaeologists have also found an ancient harbor near the pyramid complex, confirming that water transport played a crucial role in moving materials. But here's where the mystery deepens. Even with this evidence, we still don't know exactly how the blocks were raised. Think about the scale of the problem. 2.3 million blocks had to be quarried, transported, lifted, and precisely positioned. The average block weighs about 2.5 tons, but some of the granite blocks in the King's Chamber weigh over 80 tons. That's 80 tons lifted more than 200 feet into the air, positioned with millimeter precision, using technologies we can only guess at. The leading mainstream theory involves ramps, but exactly what kind of ramps remains debated. Some researchers propose straight external ramps extending from ground level to the working surface. The problem is that a straight ramp reaching the upper levels would need to be enormously long, potentially a mile or more, and would require almost as much material as the pyramid itself. Other theories suggest spiral ramps wrapping around the pyramid as it rose, or internal ramps built within the structure and later sealed over. In 2007, French architect Jean-Pierre Houdin proposed an innovative theory, that an internal ramp system was used for the upper two-thirds of the pyramid, while external ramps handled the lower portion. Thermal imaging of the pyramid has revealed anomalies, areas that cool at different rates than surrounding stone, that might support Houdin's theory. But we have no definitive proof. Without physically exploring the pyramid's interior in ways that might damage it, we may never know for certain. Some researchers have suggested counterweight systems using sand or water lubrication on ramps to reduce friction, or even combinations of multiple techniques used at different stages of construction. Each theory has merits, and each has significant problems. Here's a calculation that illustrates the incredible challenge. If the pyramid was built over 20 years, as most Egyptologists estimate based on the reign of Khufu, workers would need to quarry, transport, and precisely place one block every 2 to 3 minutes, working 10 hours a day, 365 days a year. That's an astonishing rate of construction, even with thousands of workers. It suggests a level of organization, coordination, and engineering knowledge that rivals anything in the modern world. Now let's discuss the more controversial questions, the ones that mainstream archaeology acknowledges but struggles to fully explain. The astronomical alignments are difficult to dismiss as coincidence. The pyramid's so-called air shafts, narrow channels running from the interior chambers to the outside, point toward specific stars that were significant in ancient Egyptian religion. One shaft aligns with Orion's belt, associated with Osiris, the god of the dead. Others align with pole stars that were important in Egyptian cosmology. Was this intentional celestial alignment? Most Egyptologists believe so. But how did the ancient builders achieve such precision without telescopes? The King's Chamber presents even more impressive engineering challenges. It's built entirely from massive granite blocks transported over 500 miles from Aswan. Some of these blocks weigh 80 tons or more. Even today, with modern cranes and transport equipment, moving 80-ton objects 500 miles would be a significant engineering challenge. Doing it 4,500 years ago, using only human muscle, wooden sledges, and river boats, seems almost impossible. Yet they clearly did it. And then there's the question of knowledge. The ancient Egyptians clearly possessed sophisticated understanding of mathematics, astronomy, and engineering. The pyramid's dimensions encode remarkable mathematical relationships. Pi and phi appear in its proportions with suspicious frequency. But where did this knowledge come from? How did it develop? The standard archaeological narrative holds that pyramid building evolved over generations, with earlier pyramids serving as learning experiments. The bent pyramid of Dashur, built a generation before the Great Pyramid, shows clear evidence of mid-construction design changes. The angle of its side shifts partway up, suggesting the original design proved unstable and had to be modified. The Egyptians were clearly still refining their techniques. But this evolutionary model doesn't fully explain the Great Pyramid's sudden leap in precision, scale, and sophistication. Something changed between the earlier pyramids and Khufu's monument. The jump in quality and precision is remarkable. Some alternative researchers, and I want to be clear that these are not mainstream views, though they're worth considering, suggest the ancient Egyptians may have inherited knowledge from an earlier civilization. They point to the precision of the Great Pyramid as evidence of advanced understanding that seems to appear suddenly rather than developing gradually. However, it's important to note that we have no direct evidence for this theory. What we do have is evidence of a sophisticated Egyptian civilization that developed remarkable capabilities over centuries. The gap in our understanding might simply reflect the gaps in the archaeological record. Here's what strikes me about this mystery. We can debate construction methods endlessly: ramps versus counterweights, external versus internal, gradual versus sudden development of techniques. But one fact remains undeniable: the ancient Egyptians built something extraordinary. They built something that has endured for 4,500 years. It survived earthquakes. It survived tomb robbers. It survived centuries of weathering and the removal of its outer casing stones. It survived becoming a tourist attraction visited by millions. The Great Pyramid stands today as a testament to human capability, proof that ancient people could achieve things we still struggle to fully understand or replicate. It challenges our assumptions about the past and keeps us humble about what we think we know. Every generation looks at the pyramid and asks, how? Every generation proposes answers that seem reasonable until we examine them closely. And every generation discovers that the ancients were more capable than we assumed. Perhaps that's the real lesson of the Great Pyramid. Not that ancient aliens built it, not that lost civilizations passed down secret knowledge, but that human beings, working together with determination and ingenuity, can achieve things that seem impossible. We don't need to invoke the supernatural to appreciate the wonder of the Great Pyramid. The natural explanation, that our ancestors were smarter, more organized, and more capable than we sometimes assume, is wonder enough. The pyramid guards its secrets well. New technologies, ground-penetrating radar, muon imaging, thermal analysis, continue to reveal hidden chambers and unexplained anomalies. There's still much to learn. And perhaps some mysteries are meant to endure. Perhaps the Great Pyramid stands not just as a monument to a dead pharaoh, but as a permanent reminder that human potential exceeds our expectations. That the past holds wonders we're still discovering. That the story of humanity is more remarkable than we sometimes allow ourselves to believe. What do you think? How did they really build it? Let me know in the comments. And if you want to explore more of history's greatest mysteries, subscribe and hit the bell. The ancient world has more secrets to reveal. And we're just getting started.